water in the presence of dilute esters. So that is acid catalyzed hydration. And that is Marconic of addition of water. If you have, so H plus will attach itself to the carbon atom getting more number of hydrogen, and OH minus will always be inside. That's what we have seen. And suppose if you want to get an alcohol which is in which the OH is on the outer carbon, so that is the alcohol at OH at one position. Okay. So for that we need to do anti-Marconic of addition of water, and that anti-Marconic of addition of water can be carried out using borane BH3. In the BH3, this is the solvent, ether is the solvent, or B2H6, followed by NaOH and H2. Yeah, Imad.
Good afternoon, sir.
Good afternoon. So we just started with it, and we were just discussing how can you prepare anti-Marconic of, how can you do the anti-Marconic of addition of water on alkenes. Okay, that's what we discussed. Okay. So other thing which we discussed is the preparation of alcohols by alkyl halide, and that is by nucleophilic substitution reaction. You prepare alkyl halide and you react them with the aqueous KOH. And aqueous KOH, OH minus comes in and displaces away the halide ion, and you get an alcohol, right? And that's what we discussed. We discussed Rayan, the preparation of alcohols by catalytic hydrogenation reaction. And in that we took H2 hydrogen catalyst, and other one is the preparation of alcohol by, today we have to start this, by LiLH4 and NaBH4. Okay, these are actually hydride donors, right? What their structure look like. Li is the cation and AlH4 is the anion. Similarly, in this case, sodium is the cation. And this is the anion. Actually, here in both the places you can notice that there is one H minus extra. H minus is extra in both of them. Okay, so this H minus can come out and can react with aldehydes and ketones. So reduction. So today we have to start reduction. Of aldehyde and ketones by LiLH4 and NaBH4. Okay. So if you take an aldehyde actually has some amount of little positive charge on the carbon and partial negative charge on the oxygen, because oxygen is more electronegative. It has more tendency to attract electrons. As a result, this carbon is having plus charge and the oxygen is having partial negative charge. Right, Imad and Ryan? Is it clear?
Yes, sir, clear.
And suppose if you take LiAlH4, so actually this is nothing but H minus because it is 4H minus. So that H minus is going to come and join over here. Because H is minus, carbon is plus, they are going to get attracted. This is nucleophilic addition here. And because the H minus is coming and joining in on the carbon, the pi bond of the carbon, double bond, carbon can make only 4 bond maximum. So the pi bond will get shifted on oxygen. So that's how the reaction happens. RCH. One more H came in from LiLH4, O minus and Li plus. Right? This is how the reaction took place. And then you put water. So water actually, yeah, Anushka, good evening. Can you hear my voice?
Yes, sir, I can hear.
So this water will bring in. So we were discussing the reduction of aldehyde and ketone by LiLH4 and NaBH4 by lithium aluminum hydride and sodium borohydride SPH. Okay. Rayan, Imad, is it clear?
Sir, can you just explain that again?
Yeah. Actually, this LiLH4 is Li plus, aluminium 3 plus, and think as 4H minus. Okay.
Yes,
So if you add the charges, it is going to be neutral. LiLH. So these H minus which are there on the aluminium, they come and join in on the aldehyde.
okay.
And the aldehyde, the double bond of the aldehyde will get shifted to O minus.
Okay.
This H is this one, O minus. And once you have that O minus, you put water for neutralization and it will become OH. Right?
Yes, sir.
Clear? So that's how the reaction will progress. Rayan, Anushka, is it clear?
Yes, sir, clear.
Clear, sir.
Okay, good. NaBH4 if you take, in water, what is going to happen? The H minus is going to come and join in on the carbon atom. O minus will form and it will, water will bring in H plus, so OH. Okay. Is this clear? So it's given in your NCRT also. And this one. This is catalytic hydrogenation reaction in which you can take palladium. Sometimes it is written as palladium and carbon. So this is one and the same thing. Actually, you take the carbon powder, you could do the coating of palladium on that carbon. Or platinum is written, or NaBH4 and H2O. Sometimes they just write NaBH4, that will also work. Okay. Clear? And if you take carboxylic acid and all its derivatives, they also get reduced and give you alcohol. Because it is having more hydrogen, so it is going to come and it is going to attack and it is going to convert the carboxylic acid or any of its other derivative like acid chloride and all to alcohol. Okay, clear? So what you can do is, suppose carboxylic acid is there. Carboxylic acid is having COOH group. You can reduce it with LiLH4. So it is going to change to CH3CH2. Okay. Or esters also you can take. What are esters? Priyan, Anushka, Imad, tell me quickly. What are esters? Esters actually have one CO. They are actually derived from carboxylic acid. So you have O and another alkyl group is there that has come from alcohol. Okay, this is an ester. Or simply you can write ester. Okay, and if you react it with LiLH4, this is going to break into two fragments, and you will get two alcohol group. One already it was there, which was joined to carboxyl C double bond O. That was one, right? And another was in the form. So this OCH3 was there and CO was there. So this will get reduced. This portion, you add hydrogen to both of them. Okay. So what you can do, you can add one H here, one H here. So that will change to CH3OH and CH3CH2. And you can put more hydrogen on double bond oxygen. So that will also change to CH2OH. Is it clear? Imad, Anushka, Priyan, tell me quickly.
Yes, sir.
Okay. So, but if you take NaBH4, NaBH4 is actually a weak reducing agent. It can reduce only alcohols, it can reduce only aldehydes and ketones, but it cannot reduce carboxylic acid or the functional groups which are derived from carboxylic acid. So this is actually carboxylic acid derivative because it is a carboxylic acid ester. So no reaction. Okay. Clear?
Yes.
So you can write NaBH4 sodium borohydride is a weak reducing agent. Due to which it can reduce only aldehydes and ketones. This is aldehyde and this is a ketone. The carboxylic acid and its derivative can be reduced by okay. Anushka, is it clear?
Yes, sir, clear.
So NaBH4 will not reduce esters. That thing you should keep in mind. Okay. So I hope it is clear to all of you.
Yes, sir.
So it's there. Esters can be reduced by catalytic hydrogenation also. Or it can be reduced by LiLH4 also, but LiLH4 is expensive, so we use it less. Okay. So we use directly catalytic hydrogenation reaction, or we can use LiLH4. But NaBH4, if you would have taken, then it will not reduce carboxylic acid or esters. Okay, that thing you should keep in mind. The other thing is preparation of alcohols by Grignard reagent. So what are Grignard reagent? Tell me. Suppose you have alkyl halide CH3Br. Okay, you heat it with magnesium. And that changes into CH3MgBr. And this CH3MgBr, Mg got inserted between the carbon and the halogen. This reagent is known as, the general name for this type of reagent is and this Grignard, yeah,
Yeah, does Grignard reagent form carbon bond?
yeah, there is a carbon metal bond. So these Grignard reagent are in the category, they are called organometallic compound. Organometallic compound means there is a carbon metal bond. Carbon metal is bond is present in Grignard. You can see over here. This is CH3, magnesium, and bromine. If you treat it as completely ionic, if you think in terms of ion, this will be CH3 minus, Mg plus 2, and Br minus. Carbon will have minus, but it is not completely ionic, somewhat ionic. It is between ionic and covalent. But because magnesium is plus 2, that we know. So magnesium will be plus 2, carbon will be minus, Br will be minus. Okay. So it will have partial negative charges. If we assume it to be totally 100% ionic, that carbon will have minus charge, and if we assume partially negative, partially positive, it means it is somewhat covalent and somewhat charges are there. So a small amount of charges are represented, Ryan and Anushka and Imad, by putting delta. Delta represents small amount of plus charge, partial charges or negative charges. Is it clear?
Yes, sir.
So how do you prepare Grignard? That is very simple. You take alkali, you take pieces of magnesium are there, you heat it in the presence of ether. Ether is actually used to mix alkyl halide and magnesium. The ether should be free from any water, it should be dry, it should not contain water or alcohol. Okay. So this carbon is minus. There is a carbon metal bond and carbon magnesium bond. So because the carbon metal bond, such type of compounds fall under the category of organometallic compound. Right, carbon magnesium bond is there. So how will they react? Think them as minus. That's it. And if you think them as minus, you can do any reaction of Grignard. Any reaction you can do it. Very easily you can. Anushka, Imad, right? Any reaction you can do it.
Yes, sir.
Right?
Yes, sir.
So that you need to think. Okay. So how let's do some reactions. Okay. And why we are discussing Grignard here, because we are going to use these Grignard reagents for the preparation of alcohols. Okay. So alcohols, how can we make? Suppose if I take CH3 MgBr, and if I react it with smallest aldehyde is which one? Can you tell me? Can you tell me which is the smallest aldehyde? Imad, Anushka?
So from this reaction, CH3 and
No, overall, smallest aldehyde.
H3C.
Yeah, actually you need to have hydrogen smallest aldehyde, just one carbon and double bond. But this is which aldehyde? Methanol. Okay. Or formaldehyde. This is the common name. Okay, smallest aldehyde. And how the reaction is going to happen here? That can you tell me? This minus is going to come and join over here. So this carbon of aldehyde, oxygen is negative, so carbon is positive. In Grignard, the magnesium is positive, so carbon is negative. So in aldehyde, you have taken carbon with positive. Okay. And in Grignard, you have taken carbon with negative. And both of them are going to come together and join to one another. Okay. And what is going to happen? The double bond is going to get shifted on you. Is it clear? Rihan, are you getting what I am trying to say? Carbon will make only 4 bonds, Imad. So if the methyl is coming in and joining Anushka, I need to push away the pi bond on oxygen. O minus. Is it clear?
Yes, sir.
So the carbon minus has gone and joined itself on the methanol. Right? And O minus has formed. And where the magnesium will go? MgBr plus. Okay, this is first step. This is called nucleophilic addition reaction because the alkyl group is coming in and joining on the aldehyde. Nucleophilic addition reaction. Okay. This is nucleophilic addition reaction of Grignard, in which the R minus has come and joined itself on the aldehyde. And the next step is putting water and some H plus. So that H plus is going to get attached to that O minus. So you will have OH. Is it clear? So look what we have done, Ryan. So this portion was from aldehyde. And this is from water. And this is from Grignard. Is it clear? So if you react the smallest aldehyde with a Grignard reagent, you are going to get a primary alcohol. This is a primary alcohol with one carbon atom extra with one methyl extra. Okay. This is what you are going to get. If you write it in condensed manner, okay, this same, this and this also. So this is from the Grignard. Okay, this portion is from the aldehyde, middle portion H actually from the water. Is it clear? So let's do one question to understand in more detail. Okay, let's do one conversion. Yeah, Abdullah, can you hear my voice?
Yes, sir.
Yeah, okay. We were doing alcohol, preparation of alcohol from Grignard. Just started the preparation from Grignard. So let me do some questions and so that you can understand.
Okay.
So let me give you some problems. Suppose if I took ethane, Anushka, and if I react it with bromine and sunlight, what am I going to get here? And whatever I got after reacting ethane with bromine and sunlight, I reacted it with magnesium in the presence of ether. Right, Ryan? So I got something else. Okay. And that something else, I reacted it with formaldehyde. or methanol. I got a third thing. Then I reacted with H2O, H plus. I got my final product. Is it clear? So you need to tell me what are these substances which are formed in the intermediate steps. Yeah, tell me quickly. Who is going to tell me, Rayan? What is this one? Abdullah, can you try? Anushka, Imad.
No.
Yeah, what it is? So this is bromination in the presence of sunlight. So
Okay.
one hydrogen will be broken away by the bromine, and you will have CH3, CH2, Br, ethyl bromide. Right, Imad?
Yes, sir. So, but where's sunlight in this reaction?
This is sunlight. It is written as the energy of the photon is h into frequency. So sometimes it is written like this, or sometimes it is also written like UV light.
So both HV and UV are sun rays, or
UV light is the UV ultraviolet light, or H nu is the energy of that photon.
okay.
Actually, a photon of the particle of that light. So sometimes it is written as H nu also. Sometimes it is written just light,
Okay.
or sunlight, or UV light, or H nu. They're one and the same. So that you require energy to break the bromine bond.
Yes, sir.
For that, this energy is there, and then you react it with magnesium and ether. So what will happen now? Alkyl halide when reacted with magnesium. Anushka, tell me. Rayan. So what is going to happen? This magnesium will react. It will give 2 electrons. It will change because magnesium is actually having 12. So it has 2 outermost electrons. So it will give 2 electrons. And it is going to come, and magnesium is going to break this bond by 2 electrons. And it is going to come and form that a bond with the alkyl group and the bromide. So it is going to be, what should I write here, Abdullah? CH3, CH2, MgBr, right?
Yes.
So this is Grignard reagent. So all magnesium containing organic compound are Grignard reagents, and specifically, which Grignard is this? This is ethyl magnesium bromide. So as I told you, you can think as magnesium plus 2, Br minus, and this minus. Okay, magnesium is plus 2. Because it is having 2 outermost electron, it loses those electrons. Okay. So what happens then? This minus is going to come, and if you took an aldehyde, Anushka, this aldehyde, the carbon is plus, right? So it is going to come, and this minus, the carbon of the Grignard is minus, carbon of the aldehyde is plus. So that carbon of the Grignard is going to come and add on the carbon plus of aldehyde. Okay. and I need to remove one pi bond. It is a double bond. I need to remove the double bond because otherwise what will happen? Otherwise just carbon will have 5 bonds. Okay, so we can't have 5 bonds. We need only 4, right? So carbon cannot make 5 bonds. So this structure is going to be HO minus, right? And this is what I will write at the top. Anushka, what should I write at the bottom? This carbon, what should I write here? CH2, CH3, right? Clear?
Sir.
And O minus will come will form a bond with magnesium. This is going to be ionic bond, right? This is going to be the structure of that. And when you react it with water, so you are going to get the final answer, Abdullah, Riyan. That is going to be HC. So what this compound is, this compound is actually CH3, CH2, CH2 and OH. Actually, if you write it in a straight line, this is going to go. So actually this, we started with this, and this we took in the form of aldehyde, and this came from the water. So if you react the if you react the Grignard reagent with the smallest aldehyde, that is formaldehyde, you are going to get an alcohol with one more carbon atom. Is it clear? So I will write once again. RMGX, Rayan, Imad, Abdullah, Anushka.
Yes, sir.
Any doubts in this? Tell me quickly.
No.
No,
No, sir, no doubt.
So you are all, so Grignard, this is a step of reaction, means the number of carbon atoms are increased. One more carbon atom and OH, primary alcohol you will get with one more carbon atom if you react Grignard with formaldehyde or methanol. Okay. So what is the next aldehyde after formaldehyde? Next higher aldehyde. What its name or structure is? So aldehyde and ketone both have double bond oaths. So next higher aldehyde is aldehyde. At least you should have one C hydrogen on double bond, doubly bonded carbon. So first aldehyde we took, that was having H on both the sides. The next one was having H on one side, and another side you have alkyl. So, but at least you should keep one H connected to C double bond. That is an aldehyde. And which aldehyde is this? This is aldehyde. So 2 carbon atom aldehyde. So this is ethanol. Is it clear? This is ethanol. And what happens if you react a Grignard reagent? Let's say I will make a Grignard of benzene PHMGBr. pH is phenyl. So what are we going to get? Can you try, Anushka, Rayan, Imad, Abdullah? Can you try this quickly? The method is very simple. You need to attach the plus from minus and minus from plus. That's it. This is minus. This is plus 2. This is minus. Okay. Right? And CO is there. So oxygen, you can think as oxygen minus and plus on carbon. Actually, the electronegative atom, the atom which is more non-metallic, which is more on the right hand side in the periodic table, that will have the minus charge. Clear? So now try it quickly. Yeah. Iman, tell me quickly.
Okay. So,
This is minus.
yeah. So sir,
Okay.
this will attack CH3 or
This will attack the carbon atom which is having the plus charge.
yeah. C. Oh, C. Okay. Phenol.
Okay. So, and what's going to come in at the O minus position? Anushka, Priyan, tell me. So O minus MgBr, O minus will get attached to MgBr. Right? Is it clear?
Yes, sir.
Yes, sir.
And O minus MgBr, so what I'm going to get over here? Anushka, is this clear or not? Abdullah, Anushka, tell me quickly. In case if you have any doubts, I can explain it again and again, no problem. You can ask me any number of times, right? So this is the addition of Grignard, the carbon group of the Grignard on the aldehyde. Okay. Is it clear? Now what will happen? Now will you keep it as it is or will you convert it to alcohol? You will convert it to alcohol. Okay. So what you need to do, that O minus is there, you need to make it OH. So you will react it with H2O and H plus. This needs practice, okay? Little bit. Rian and Abdullah, can you hear my voice? Can you see what I'm writing?
Yes.
So I hope you understood. So let me summarize it. If you react a Grignard reagent with aldehyde other than formaldehyde or methanol, you are going to get a secondary alcohol. This is secondary. Why? Because this carbon is connected. One alkyl group was already present in the aldehyde itself. Another alkyl group came in and joined. So it is secondary alcohol. Is it clear? Clear to everyone? Tell me quickly.
Yes, sir. Clear.
right? So, and what will happen if you react the Grignard reagent with the ketone? What type of alcohol you are going to get? Anushka, why tertiary alcohol? Can you explain it to me quickly?
Sir, can you repeat?
Your voice is very low. It's very low today.
Sir, can you hear now?
Yeah, now I can hear you. So why the reaction addition of Grignard on ketone is going to give us tertiary alcohol? Just think about the structure of ketone. Abdullah, can you try? Then I will explain. Yeah, Abdullah.
Yes, sir.
So how the tertiary alcohol has formed? Just you can try it. I will explain you. Don't worry. Can you give little bit try? Imad, you can also contribute.
So that's Grignard reagent, ketone, right?
Yeah. Why tertiary alcohol? How can we explain that we are going to get tertiary alcohol?
Okay, so one minute.
So ketone, Abdullah, ketone has how many? What is ketone? Smallest ketone. Ketone is actually a compound which has carbon double bond oxygen just like aldehydes. But the difference from aldehyde is that the ketone is having two alkyl groups. Like this. Is it clear?
Yes, sir.
Sir, could you
This
just
is a
repeat?
ketone. And Grignard reagent, I can write it in a general form. R. R is any alkyl group. It can be methyl, ethyl, propyl. Okay.
Sir, but how Grignard reagent is reacted with ketone to form that 3 degree alcohol?
Yeah. So R is there. It is minus. Okay. And this
Okay.
is plus, right?
Yes.
And this is minus. So this minus is going to come and join in over here.
Okay.
So ketone already was having two alkyl groups.
Yes.
Okay. And one more alkyl group came in from the Grignard and joined itself on the ketone, carbon of the ketone.
Okay.
So what you will get? You will get CH3, CH3, R. R is any alkyl group,
Okay.
and OH. Actually, you need to do that H plus H2 also. That I have not written. Just I'm trying to.
Okay.
Actually, first you react with Grignard, you get O minus, and then you react with water. So with that, you get the OH, right?
Yes, sir. But this compulsory to react with H2O, or we can write it as the C with itself.
Yeah. It is sometimes so. It is better to write with write the H2O. Look what they have written. So first they have added Grignard. R is minus, Mg plus 2, X minus. Okay.
Yeah.
And this carbon is plus and this is minus. This is plus and this is minus. Okay. So this R minus is going to come and join in on the carbon. And so R minus has joined on the carbon, O minus, MgX. And then after reaction with water, you will get OH here. Okay.
Okay.
That's how. So with formaldehyde, look here, you have got CH2OH extra. Any other aldehyde? So one is R, another is R dash, which came in through Grignard. You will have this alcohol, secondary alcohol. So formaldehyde is going to give you primary alcohol, CH2OH. Any other aldehyde is going to give you secondary alcohol. Ketone, which already has two alkyl groups, and the one R will come and join in over here. So you are going to get a tertiary alcohol. Is it clear?
Yes, sir.
So here you are going to get a tertiary, right?
Okay.
Yeah. So that's how you need to do. So let's try some of the questions. So reaction of propanone with methyl magnesium bromide followed by hydrolysis. What are we going to get? Propanone is a ketone. Ketone, how you will know that it is a ketone, Abdullah? The name will have one in it. Okay. So propanone is this one. Prop means 3 carbon atom. This is propanone. And methyl magnesium bromide, methyl is 1 carbon atom group, CH3, Mg, Br. This minus and this is plus. This minus is going to come and join in over here, and you will have OH. So your answer is going to be this one. Is it clear or not?
Yes, okay.
So yeah, let's move to the. So this is the preparation of alcohols from Grignard. Okay, let me ask one more question, then we can move on to the phenol. Which is the correct set of Grignard reagent and which is the correct set of Grignard reagent and the aldehyde, which upon reaction will give which is the correct set of Grignard and the and a ketone. Okay. So I'm not asking you the conversion, but you need to do it. But I'm just giving you the options so that you can think more quickly. Yeah. So I have made an easy way by writing the options, but you need to write the structure of the reactant. So have you understood the question, Riyan and Abdullah? So what alcohol we need to get? Anushka? So first of all, yeah. So we can write the structure of this because just by writing the name, we can't solve. So first, what alcohol we are getting, Imad? It is 2-methyl pentane 2-ol. So let me write the structure of that alcohol.
Okay.
I will write it in some other color. I hope all of you can see it. Is it clear? Can all of you see what I have written? This is 2-methyl pentane 2-ol. Is the name clear? So there are 5 carbon atoms in the main chain. 1, 2, 3, 4, and 5. Second carbon has methyl, Imad, and second carbon, the OH is also connected on the second carbon. Abdullah, is it clear? Imad, Anushka, clear? So I need to prepare this. So which set of ketone do I need to take care? Riyan,
Second one, sir, from my side.
yeah. So second one can be the right answer, right? Because this is 5 carbon atom are there. C double bond O is taken on the second position, and the methyl is going to come and join in from the Grignard on the C double bond. Right?
Sir, can the first one also be an answer?
No, because in the first option, the ethyl is going to come and join in over here.
Okay.
So it is going to be CH3, C, CH3, and ethyl and OH. So if you count the longest chain, 1, 2, 3, and 4. So the longest chain, it doesn't have the 5 carbon atom, it is of 4 carbon. So this is 2-methyl butane 2-ol. But in the question we have written pentane 2-ol, means 5 carbon atoms. Clear?
Yes.
Okay. So this is, and will this be the answer? The 5 carbon atom are also there. But can the third option be the answer of this question? Anushka, what do you think? Can the third option be treated as the answer? Yeah, Anushka.
No, sir.
Yeah, tell me. Anushka, can you hear my voice? Yeah, I can't hear you.
Yes, sir. I don't think so. It can be.
Yes or no? Yeah.
No, sir.
Yeah, it will not be the answer exactly. Right. So it is because though there are 5 carbon atoms, okay, but the methyl is going to come. So where the double bond is, it is 1, 2, 3. It is on the third carbon atom. So methyl is going to come and join itself on the third carbon atom, right?
Yes.
So this is 3-methyl pentane 3-ol. So though there are 5 carbon atom, but the OH and the methyl are on the third position. So this is not going to be the answer. Abdullah, Can you see what I've written? Understood? Any doubt? You can stop me, you can ask me, okay?
Yes.
So this is minus, and what about this one? This is, we are not, there are just 3 carbon atom total. So this is also not going to be the answer, right? So let's move on to the next topic of preparation of aromatic alcohol. So till now we have seen how to prepare aliphatic alcohol. Aliphatic alcohol were having alkyl groups like methyl, ethyl, propyl, normal alkyl group. But now we are dealing with preparation of phenol. Preparation of phenol. Okay. So what is phenol? So this is the detailed structural formula of phenol. But as you will not have that much time, so you can write the condensed structural formula of phenol, where you don't write the carbon atom and the hydrogen atom, you just show the carbon-carbon bond by lines. While other atoms are written, oxygen is written, OH. So this is phenol. Is it clear or not? So the next is phenol, and the common name of the phenol is carbolic acid. That is very, very important. Okay. We get it from coal tar, we get the phenols from actually by petroleum products. Okay, a lot of by treating petroleum products, we get the phenol. Okay, it is actually aromatic alcohol. Why aromatic alcohol? Because the name, though it suggests that it has aroma, yeah, it has aroma because we use it as a disinfectant also. Household, common household cleaning purpose, the phenol is used. You must have observed this. And this is aromatic, not because of its aroma. That is the old concept. The new concept is the OH is directly connected to benzene. That's why it is an aromatic alcohol. So there are many methods of the preparation of phenol. So how can we prepare from the benzene? Any idea? Abdullah, Anushka, Riyan? Any idea how to prepare phenol from benzene? Tell me quickly. Yeah. So first of all, benzene is having whole hydrogen atom, and you need to bring in the OH. Okay. So OH you can bring by any OH. But NaOH, if you bring in, that is going to displace this any atom which is already there, mostly Cl. So first you need to bring in the Cl. And how can you bring the Cl on the phenol? Imad, this is not photohalogenation, right?
Yes, sir.
Photohalogenation takes place on alkyl groups, normal aliphatic groups. On the benzene, we use electrophilic aromatic substitution. The FeCl3 breaks the Cl minus, Cl plus will form That's what we have seen in alkyl and aryl halide chapter. Cl plus and FeCl3 is having only 3 bonds, so it will break away the Cl minus. And this Cl plus is going to come and join in on the benzene ring. Okay. Anushka, is it clear? This you can revise the alkyl halide chapter.
Sir,
Yeah,
sir, could you explain this again?
yeah. This is the mechanism. Little bit mechanism you should understand. I will. Yeah, I am explaining. No problem. What you can do is, so there are hydrogen everywhere. So what I did, I just wrote one hydrogen, any one you can write, and you can remove the HCl. And you can put the Cl on the position where the H is removed. So you will get chlorobenzene. You can write it on any carbon or either on this one, all are same because it is a hexagon. HCl is removed. But how it happens, this is the mechanism. So FeCl3 comes and join on the chlorine and it breaks away Cl minus, leaving behind Cl plus. This Cl plus will take the electron from the benzene and it will get connected. Hydrogen was already there, but now I am showing it. And because the Cl plus has joined itself and by taking the electron out of the benzene, so you will have a plus charge on the position adjacent to the where the Cl has attached itself. And now what will happen? We need to get back the benzene ring. And how do we get the benzene back? The Cl minus actually, which was earlier taken away by the Lewis acid catalyst, this is the catalyst, will come out, will come again and it will break away the H plus, the electron will get back into the benzene. So this is the mechanism. Okay, this is electrophilic aromatic substitution. This is not the substitution in the presence of light, which we used in alkanes. This is the substitution which has taken place on benzene ring, aromatic ring. And you, because benzene is electron rich, so you took the Cl in the form of Cl plus. And how that Cl plus was generated by taking FeCl3, which will break away the Cl minus. And that Cl plus has joined itself on the benzene by taking its electron. And finally, that Cl minus, which was taken away by FeCl3, that will come again and take away the H plus from the position where the Cl plus was connected. Okay, this is the mechanism, but this is very important. So you need to know the mechanism also. Mechanism is required only for certain few reactions, not for all the reactions. Certain few reaction, basic detail, basic things you need to know. Okay, is this clear?
Yes, sir, clear.
Abdullah, Rayan, Imad, tell me.
Yeah, understood.
And now what happens? So you have chlorobenzene. Okay, so by taking Cl2 and FeCl3, but on the alkane, you what you take? You take on alkanes you take Cl2 and light, but on benzene you take Cl2 and FeCl3. Okay, so chlorobenzene. This chlorobenzene, you react with NaOH at a very high temperature. And pressure. You require very high temperature, so this OH is going to come in and it will remove the Cl. So OH is going to be in the form of O minus because it is basic medium. Okay. So you need some acidic acid also to make it OH. Or sometimes it is not written also. Is it clear? So this process, acidification, phenol is obtained by acidification. So this is OH. Initially you have taken NaOH, very high temperature pressure, 350 degrees Celsius. OH minus is going to come in, just going to push away the Cl. But in basic medium, this OH minus will become O minus. So you need to do the acidification. Okay, what this process is known as, what's the name of this process? Can you tell me? Rian, Abdullah, Anushka, Imad, what's the name of this process? Now, who's going to tell me?
Is it Grignard?
It is something different. It's not Grignard. It's actually Dow's process. In the Dow's process, you treat chlorobenzene with NaOH at very high temperature and pressure. And that's OH, that gives the OH minus sufficient energy to come and remove the Cl. Is it clear? That is Dow's process. Okay. So just simple, but you need to take very high temperature. The second step is also same, but actually what's the need to, actually it appears that we wanted to prepare phenol, but why we prepared chlorobenzene in the middle? Yeah, Anushka, can you explain me?
Sir, could you repeat?
Actually, we wanted to prepare phenol, preparation of phenol from benzene, but why we actually initially prepared chlorobenzene? Can't we have directly phenol from benzene? Why we earlier we converted it to chlorobenzene and then chlorobenzene was reacted to give you NaOH? Why?
Sir, I'm not sure.
Are you getting what I'm trying to ask?
Sir, I understood your question, but then I'm not really sure of the answer.
Yeah. So you can just try, no problem. I will explain.
Sir, probably because it would be easier and probably even faster to first convert it to chlorine and then.
Yeah. Actually, suppose this Cl and all, they are leaving groups. They can come out. So directly on benzene, we were not able to react. We actually first made chlorobenzene and that NaOH came in, OH minus came in and that removed OH, Cl minus. So directly, Abdullah, can you hear my voice? Yeah. Rian?
Yeah.
Okay. So directly Suppose if I ask you from phenol, from benzene to phenol, directly it is not possible. So first you bring in some group which can be removed easily, that is Cl. And that Cl, so how you brought in this Cl? By reacting it with chlorine and FeCl3. You can write Fe or FeCl3. But you don't need any light. Then you react it with the NaOH. Heat and pressure. So you ended up with O minus Na. Last step is acidification. This is how we got the final product. Is it clear? Rian, Abdullah, is it clear or not? Imad?
Yes, sir.
And this process via chlorobenzene to phenol is known as Dow's process. Dow is a very big chemical term. Okay. Right? So other method is from benzene So other method is via sulfonation. So again, you can't have OH group directly connected on the benzene, because benzene at all position you have hydrogen, right? And the hydrogen will not be removed so easily. It is a very strong one. So you bring in some group which can be removed easily, and then you bring in the OH minus so that group can be substituted. So in the upper case, Dow's process, it was chlorine, which you attach by the means of chlorination. In this one, it is sulfonic acid group, SO3H. You can take concentrated H2SO4, or you can take SO3. You can heat them together. So H plus will be removed and you will end up with, I'm not writing the mechanism, I'm directly writing the product. So this is benzene sulfonic acid. Then you reacted that benzene sulfonic acid is heated that by strong NaOH heat. So OH minus will come in and push away the SO3H. It will be initially SO3Na. You will do because it is basic medium, so you can write it SO3Na also, directly also you can write, right? Followed by acidification. Not SO3Na, ONA, sorry. OH minus has substituted the sulfonic acid group, and it will be O minus, and you will take H plus acidification to make it OH. Okay, that's how we have prepared phenol. So from benzene you can make chlorobenzene and then put NaOH and followed by acidification. For benzene you can mix benzene sulfonic acid, then you can react it with NaOH under heat and pressure. So SO3 group will be removed, right? And you will have OH in place of SO3. Is it clear to all of you? Now, the next method is, so these two methods are there, so both are very, very important. Do keep this in mind. Okay, this is oleum. Oleum is concentrated H2SO4 which has SO3 in it. Okay. The other method is via diazonium salt. So who is going to tell me how diazonium salts are prepared? Himad?
Yes, sir.
What are diazonium salts?
Those salts that are dissolved as
No, N2 plus group.
yeah.
Okay, diazonium salts are prepared by aniline. This is aniline. When reacted with NaNO2, NaHCl under very low temperature, the NH2 group is changed to N2 plus. Okay. Now this is treated with water or dilute H2SO4. This N2 group is a very good leaving group. It will come out and the water will come and join in place of N2. So you will have phenol. Clear? Is it clear or not? Anushka, Imad, Ryan.
Yes, sir, clear.
Okay. So that is by diazonium salts. So diazonium salts are prepared by treating, or sometimes it is written, sometimes it is also given as HNO2, nitrous acid, or it is actual formula is like this, OH and NO. So nitrous acid is not there in the lab, so we prepare it by mixing NaNO2 and HCl, and with nitrous acid, the aniline is going to change to diazonium salt. And diazonium salt is heated with dilute sulfuric acid in the presence of water. So that is going to, the water is going to attack on the diazonium compound. The N2 will break away because N2 gas is very stable. We know that our atmosphere has more than 70% nitrogen. So N2 is going to come out, and in place of N2 you will have OH group connected. So that is going to be the phenol. Is it clear? Imad, Ryan, Anushka,
Yes,
Abdullah,
sir.
is it clear or not? Okay, so today we have seen three methods of phenol preparation. Dawes process, that is by chlorobenzene and NaOH, By sulfonation, that is by concentrated H2SO4 plus SO3, that is oleum. You will get benzene sulfonic acid, then NaOH. Third method is by diazonium salt. Okay, so let's cover some more things on the next time. In the meantime, you can do the practice questions from this cumene hydroperoxide method. We will cover it on the next time. Meantime, you can practice these reactions, Grignard. Okay, this all we did. Okay, and some questions of Grignard from the back exercise. Okay, that you can try. So let me end today's class.
Sir?
Okay. Yeah.
Sir, my exams will be starting from 10th of October. So, when will the revision classes start?
Yeah, you can tell me, or you can, if you want, certain different topic need to be done, or which is not coming, which we have not covered. Okay, you can book some extra time. Okay, or in the morning also you can book some extra class if you are available. You can coordinate uh, with the management and they will schedule extra class. Okay, and just before your exam we can have some, we can go through, you can tell me which chapters are coming and we can have the revision also, right?
Yes, sir. Sir, I've actually shared all the timetable and the portion for physics and chemistry both with the manager, and I've been
Yeah,
asking the
yeah,
questions.
yeah. Okay, okay, okay. So next